Now that we've looked at some of the basics on plotting points, let's look at graphing equations. When we're dealing with an equation in two variables like x and y, the idea is to find all of the points x, y that make the equation true. So the point of a graph is it's a representation of the solutions to the equation. It gives us a picture for the solutions. And there's several different ways to plot equations, but we're going to start with what's called the point plotting method. Let's consider this equation, 2x plus y equal to 1. The point plotting method starts with just setting up a table and sticking in a few values for x or for y, and then figuring out what the other variable needs to be. So, my first example, 2 times negative 2 plus y equal to 1. So I would have negative 4 plus y equal to 1. Adding 4 to both sides gives me that y would be 5. If I let x be negative 1, I would have 2 times negative 1 plus y equal to 1. Or negative 2 plus y equal to 1. Adding 2 to both sides gives me that y is equal to 3. And you can continue this pattern. You would get 1, negative 1, and negative 3. Now that I have some idea of the coordinates, I can start actually graphing this. So, we can set up the coordinate plane. We need to go over negative 2 and up 5, over negative 1 and up 3, over 0, up 1, over 1, down 1, and then over 2, down 3. Now that we have that, we just connect the dots. While my graph isn't perfect here, you do get the general idea. Let's look at a few more. Y equal to negative x squared plus 4. Once again, I'm going to pick some numbers for x and y, or pick some numbers for x and solve for y. Let's see, negative 2 squared is 4, so I would have negative 4 plus 4 is 0. Negative 1 squared is 1, so negative 1 plus 4. Negative 1 plus 4, 0 plus 4, negative 1 plus 4, and then negative 4 plus 4. And this is a 4, not a 0. Now that we have that, we can graph. I have negative 2, 0, negative 1, 3, 0, 4, 1, 3, and 2, 0. Once again, we just connect the dots to get a general idea of what the graph looks like. Let's look at one more example. Y equal to the absolute value of x. The absolute value just gets rid of the negative sign, so absolute value of negative 2 is 2, negative 1 would be 1, and then 0, 1, and 2. So as I'm graphing this, I have negative 2, 2, negative 1, 1, 0, 0, 1, 1, and 2, 2. We can then connect the dots to get the V shape of the absolute value graph. While we're dealing with graphs of equations, there is one useful piece of information called the intercepts. There are two types of intercepts, x and y. The x-intercept happens whenever y is equal to 0. It's where our graph intersects the x-axis. The y-intercept happens whenever x equals to 0. It's where the graph crosses the y-axis. So if we want the x-intercept, we set y equal to 0. For the y-intercept, we let x be equal to 0. Let's try to find the intercepts of this equation. For my x-intercept, I need to let y be equal to 0. So 0 is negative x squared plus 4. I'm going to add x squared to both sides to get it positive. That gives me x squared is equal to 4. And then I can take plus and minus the square root. So my x-intercepts are 2 and -2. For the y-intercept, I'm going to let x be equal to 0. So I have -0 squared plus 4, which is just 0 plus 4, or 4. So my y-intercept is y equal to 4. We can also determine intercepts from a graph. So here the x-intercepts are where we cross the x-axis, which we can see is at -3, 2, and 5. Y-intercepts are where we cross the y-axis, which in this case is just 3.